Visit Chandra's beautiful universe. Eta Carinae. After taking snapshots for over 20 years with NASA's Chandra X-ray Observatory, astronomers have learned important new details about an eruption from Eta Carinae witnessed on Earth in the middle of the 19th century. Chandra data from 1999, 2003, 2009, 2014, and 2020 have been combined into a new movie of Eta Carinae. Astronomers used these Chandra observations along with data from ESA's XMM-Newton to watch as the stellar eruption from about 180 years ago continues to expand into space. Eta Carinae is a system that contains two massive stars. One of the stars is about 90 times the mass of the Sun, and the other is about 30 solar masses. In the middle of the 19th century, people on Earth watched as Eta Carinae temporarily became one of the brightest stars in the sky. During this event, which astronomers call the Great Eruption, Eta Carinae ejected between 10 and 45 times the mass of the Sun. This material became a dense pair of spherical clouds of gas, now known as the Homunculus Nebula, on opposite sides of the two stars. Fast forward to the 20th century, when astronomers developed new tools to study Eta Carinae. About 50 years ago, astronomers used the Einstein Observatory to discover a bright ring of X-rays around the Homunculus Nebula. Later, they looked at it more closely with Chandra. The new movie of Chandra observations over 2 decades, plus a deep image generated by adding the data together, reveal important hints about Eta Carinae's volatile history. The new data also reveals a faint shell of X-rays outside the bright X-ray ring. The astronomers associate this shell with a blast wave from the Great Eruption. Because the newly discovered outer X-ray shell has a similar shape and orientation to the Homunculus Nebula, the research team think both structures have a common origin. The idea is that clumps of material were blasted away from Eta Carinae well before the mid-1840s Great Eruption, sometime between 1200 and 1800. Later, the blast wave from the Great Eruption tore through space and collided with and heated the clumps of material to millions of degrees, creating the bright X-ray ring. The blast wave has now traveled beyond the bright ring. A detailed analysis shows that the Great Eruption likely consisted of 2 explosions. First, there was a quick ejection of low-density gas, which produced the X-ray blast wave. This was followed by the slower ejection of dense gas that eventually formed the Homunculus Nebula. While Chandra has revealed so much about Eta Carinae, the story isn't done yet. Astronomers are eagerly awaiting the next episode of Data to find out what happens.